Welcome to Math for Juniors with me, Miss Marks, and my assistant, Snail. Oh God, he's dreaming! Snail!
Ouch!
What were you dreaming about?
Miss Marks, I watched a movie yesterday. It had beautiful submarines. The hero drove it to 400 feet below the sea level.
Ah, interesting. You know the distance below the sea level can be represented by a negative integer? So we can say that it was at minus 400 feet.
Oh,
So did the hero bring the submarine up, huh?
yes. To fight the villains, he brought it 200 feet up.
So using the concept of addition of integers, tell me at what distance did the submarine reach at that time?
Minus 400 plus 200 is equal to minus 200. So, the submarine was at a distance of minus 200 feet. That is 200 feet below the sea level. Miss Marks, I wonder, do we always get an integer when we add or subtract?
Actually, Snail, we have various properties based on addition and subtraction of integers, and knowledge of that will give you a better picture of the question you asked. So let's quickly get into the virtual world and learn about the properties of integers. Many situations in our day-to-day life can be answered by using two fundamental operations: addition and subtraction. Let's explore some properties of these operations for integers in this module, where we study the closure property for the operation of addition and subtraction of integers, and then see the commutative and associative properties for these operations, and finally learn about the identity and inverse for the operation of addition. Let's begin with the first property called closure property of integers. Take any two integers, say minus 12 and 25. On adding, we get 13, which is an integer itself. This property will hold true for any two integers being added. So in general, for any two integers a and b, a plus b is equal to c, which is an integer. Let's see if the closure property holds true for the subtraction of integers too. Let's subtract 4 from minus 6. The answer is minus 10. Similarly, minus 26 subtracted from 30 results in 56. Notice that the answer in both the cases is an integer. So we can say that integers follow closure property during subtraction as well. Which means if x and y are integers, x minus y will also be an integer. Snail, tell me one thing. Every evening, which homework you do first? Math or science?
I usually do math homework first and then science.
So, will it make any difference if you do science homework first and then math?
I don't think so. It will take exactly the same time.
Yes, and that's what we call commutativity. By changing the order of two things, the end result doesn't change. Let's see in the virtual world if this property holds true in case of addition and subtraction of integers as well. Let's now see the second property of integers. Well, adding sugar to milk or adding milk to sugar does not really make any difference. Does this hold true in case of numbers too? Let's change the order of integers while adding them and see what happens. 7 plus minus 8 whole equals minus 1. minus 8 whole plus 7 equals minus 1. So, 7 plus minus 8 whole equals minus 8 whole plus 7. This is called the commutative property. The name itself describes the property, as the word commutative means commute or move around. So we can say that in general, for any two integers x and y, x plus y is equal to y plus x. Does this commutative property hold true in case of subtraction as well? Let's see through an example. 6 minus minus 2 whole is 8. Whereas minus 2 minus 6 is minus 8. We see that changing the order changes the answer. Hence, subtraction of integers is not commutative. Which means in general, for any two integers x and y, x minus y is not equal to y minus x. Now let's take a slightly more complicated situation. Let's try to extend this property of changing the order to the addition of three integers. Consider an example of scores of a contestant in a quiz competition, which are 6, minus 7, and 5. Now we add them in groups and see if the order is important. First, let's add minus 7 and plus 5. It is minus 2. Adding 6 to it gives 4. Next, let's first add 6 and minus 7, which is minus 1. When added to 5 gives 4. So, 6 plus minus 7 plus 5 whole equals to 6 minus 7 whole plus 5. In other words, for any three integers x, y and z, x plus y whole plus z equals x plus y plus z whole. This property is called associative property. The word associative comes from associate or group. It refers to grouping. So the associative property holds good for integers. Welcome back, friends, to the real world. Snail!
You scared me, Miss Marks.
You were sleeping again, huh? That's really an awful habit of yours to sleep during session.
I'm sorry, Miss Marks. I won't sleep from now on. Actually, I was not sleeping. I was thinking.
Stop lying, Snail. We will decide your punishment later. Right now, let's enter the virtual world to learn more about integers. Keep your eyes wide open and be attentive. An arithmetic operation works to change numbers. But when 0 is added to any integer, nothing happens. The number remains the same. This is only true in case we combine an identity with respect to addition with another number. So 0 is called the additive identity for integers. That is, a plus 0 is equal to 0 plus a is equal to a for any integer a. Now, what should be added to an integer, say minus 3, to get the identity element, that is 0? Well, it's negative, of course. That is negative of minus 3 or 3. So 3 is the additive inverse of minus 3. In general, additive inverse of a number yields identity element or 0 on adding. For an integer a, minus a whole is the additive inverse and vice versa. Back to the real world.
Wow, it was interesting to know about the number 0. But Miss Marks, I was wondering, how was the number 0 discovered?
Let me tell you about it in the Do You Know section. Do you know that 0 and negative numbers were first used in 300 BC? That is much later after the development of the numbers like 1, 2, 3 and so on.
Really?
Yes, and to add to your surprise, in the Babylonian system, 0 was represented by a space.
You mean if they need to write 105, they would write it as 1 space 5.
Yes, but this became confusing when numbers which had multiple zeros next to each other were to be written.
Then what did they do for writing those numbers?
1500 years later, Babylonians finally began to use a special sign for 0, but it was used as a placeholder and never as an actual value.
Then how and where did the proper use of 0 started?
The concept of 0 as a value as well as the concept of negative numbers first appeared in India around 600 AD. But it was only in the modern times that the value of 0 and negative numbers was well understood. Alright friends, time to take a memory jog. So sit tight and pay attention. In this module, we have learned the following. Integers are closed under addition and subtraction. Addition is commutative as well as associative for integers. 0 is the additive identity for integers. Additive inverse of a number is its negative. Well friends, it's time for us to go now. See you next time in